So my name is John Scott, and I'm going to talk about using Postgres for 14 years in production in an industry called critical messaging, which is kind of a niche market. Hello? I'm going to describe starting development in Postgres actually in 2000, and we went through 3 major applications, plus a lot of small applications, all of which are still in production up to the present. So I'm a full-time consultant at a company called Interim Messaging, which is based here in Dallas, actually in Lewisville, Texas, which is a suburb. I work in the Internet Applications and Engineering group, and we work closely with the network operations people. So they're the folks that have the big NASA heads-up displays that monitor our network 24 hours a day. And most of my background is in Unix and relational databases going back to 1982. I worked on a system called Britton Lee, which is one of the very first relational database machines. It was acquired by Teradata eventually. A lot of the Postgres programmers, like Mike Olson, who was one of the very early on the Ingress project, worked for Britton Lee, and I worked with. So my provenance literally for Postgres/Ingress goes all the way back to 1982. Here's Interim Messaging. We are a small company, about 200 people. We have over 1,000 major hospitals in the United States are customers of ours. So what we provide is something called critical messaging, which most of the world knows as paging, but paging isn't so sexy, so we call it critical messaging. So there's the pager. Today's pagers do not look like this. They look more like little mini iPads. But that's basically the doctor's pager. It runs on dedicated frequencies. We license the frequencies to the FCC, so we have exclusive rights to them in the hospitals. It is technically paging. American Messaging, the company that runs this, we are the second largest carrier in the United States. Sometimes we're the first largest, kind of depending on how you measure size. We have about 60% of all the hospitals in the country. 60 to 70% of all the hospitals in the country use our gear. Our radio frequency network covers 98 of the top 100 metropolitan areas in the country. So the pagers are mobile like cell phones, which is, of course, a big plus over Wi-Fi, especially in critical messaging. We are a private merger of a bunch of major carriers that evolved during the 90s. The biggest one is Verizon Wireless. Actually, Verizon was created in 2000, but the predecessor company of Verizon, which was GTE. We are a merger of Verizon Wireless's critical messaging. We're also Skytel's. We run the Skytel network infrastructure, which is more commonly known as the original BlackBerry network. So BlackBerry started on Skytel. It's probably the best-known brand name of the companies that we run. That's a two-way network, like a cell network. And we're also a merger of a company called AirTouch out of Dallas, which is a big paging carrier, and then Singular, Southwestern Bell's paging network, and then a lot of smaller companies. We acquire about 2 to 4 companies a year. Typically every quarter we're getting another smaller carrier. I spend quite a bit of my time merging a lot of the technical aspects involved with the M&A stuff, and I'm usually one of the points on merging their technology into our network. Here's an overview of our network. This is about 80% of our traffic. I like to say that what we do is we bounce text messages off satellites, which sounds a lot more interesting than paging. So data comes in on an uplink to a satellite, comes down to our amplifier network here, and the page gets amplified, say in the Dallas area. It uses a protocol called simulcast, which people in the signal industry, it is a way of talking. Each pager can talk to simultaneous towers at one time, which is something you can't do very easily on a cell network. So if a tower goes down, we still get decent coverage. Typical metropolitan area like Dallas will have 50 to 100 of these. It's easy for us to set these towers up at hospitals. It's inexpensive. This is a one-way network, so these devices can't answer back. We do manage the two-way network also, which is basically Skytel right now. That is more like you would traditionally think of as a cell tower network. So it also has a simulcast protocol, and so the pagers are talking back, and they come back over a dedicated link set up in the tower, where the tower's set up. and back into our data center here in Dallas. We have 2 other DR centers, but our main data centers are here in Dallas and then out on the internet. So the SkyTel network is the main network that runs this. That's just something where between 15% of our traffic runs like this. Maybe a little less. This is declining. This is the network that competes with the cell network. So a typical customer of American Messaging would be first responders, ambulance drivers. That's anybody, firefighters in Southern California. Most of them carry our gear. Paging works really well in smoke, and it's easy for us to crank up the power all the way out to the satellite. We can do it to penetrate through. We can set things up. We can set up coverage in areas, for example, where fires are breaking out and everybody's getting out and we're going in. We also, our typical customers are hospitals and healthcare. And another area is that you don't think about a lot is what's called just-in-time inventory. We have 2 major car manufacturers in Detroit that started out years ago using pagers as a way of saying, hey, I need somebody in the factory floor, I need X. And a message gets broadcast out and somebody picks it up and delivers it or coordinates it. They're still using those systems. They're inexpensive to run. And another area we're pretty good size in is what's called remote control telemetry. So air conditioning systems in Vegas, you can turn on and off, you can send weather reports over the satellite. You can also turn on and off devices, send controls to the individual devices. It's inexpensive. When you have air conditioners way up in the top part of the building, it can be hard to get cell towers in there, so they use our gear. We can put a repeater right on top of the roof very easily. We have over 1 million paying devices. We think there's a lot more than that. These are the ones that are paying on account. And the reason we think there's a lot more than 1 million is because we have, in the early days, the protocol is open. And we had customers that reverse engineered and built their own devices. So sprinkler systems, they're trying to keep the cost down to $1 a month or something per customer. They would build their own device, and then they would overload the payload with the address of the device. So because it's a broadcast, and every now and then somebody will have a $12 bill cut off, and their whole network will go out in Southern California, and we'll get a panicky phone call from them. So we think there's more than 1 million. This is what's on the books. So this is a slide from the lobbying group out of DC, the critical messaging lobbying group. And the x-axis here is number of devices receiving the message simultaneously. And then the y-axis is minutes it takes to deliver it. So what we're commonly compared against is SMS. Text messaging is the most common thing we get compared with. So the red line here is paging. And the top dark blue line is talking to a single SMS cellular carrier. And then the middle blue line is talking to 4 cellular carriers, because in a typical environment in a hospital, each doctor has his own. One will be on Verizon, one will be on AT&T. So you get some parallelism, but what most people don't realize, SMS is point to point. So if I want to send a message to 1,000 people, 1,000 firefighters, I would have, because fires are breaking out in Southern California, I'd have to send 1,000 messages out. We have been involved in cases debugging where, for example, the Virginia Tech incident we were involved with, where the cell towers do spam filtering. All the way out to the cell. There is throttling that occurs all through the SMS network. One thing that we see is that sometimes the throttling, this latency will get much higher than even 10 minutes. So we've seen towers, Sprint, we had some issues particularly bad in the Virginia Tech. And so this is not reflected. So what we can do is what's called over-the-air programming, which allows us to define what groups you are in. So you have a shift change on the doctors, you can change the group, so only one message has to go over the air to hit 50 different pagers at one time. So that's one of our big advantages over SMS. Of course, we're constantly in competition with SMS, and we are still technically kind of a niche market. So anyway, let's get on to Postgres. So Postgres has been used at AMS, or its various ancestral companies, since 2001 in production. We actually started doing investigation in 2000. I think it was late 2000. And I went out to the open source database conference sponsored by O'Reilly and met Bruce and Tom Lane. And because I knew the background of Postgres being from Ingress, and my experience with it through Britton Lee, I knew it was pretty good provenance. And we were, at that time, this was 7.4, I believe, maybe 7.2. We have a very long history of using Postgres with American Messaging. We may have one of the longest for a significant company in production. As far as I know, every engineering app based on Postgres is still in production, all the way going back to 2002. I'm going to talk about 3 of them, but we use it scattered out. We use it all over the place in lots of smaller apps. As our CFO said, this is the epitome of a profitable rate of return on investment. It doesn't get any better than free. So all the money gets distributed as bonuses. That's a good thing. So I'm going to talk about 3 applications of Postgres that we used. The first one that we used, which was the very first one, and this was with Verizon, the company that was a simple dispatch system. It's branded as something called MyAirMail. It looks like Hotmail or any other kind of typical web mail type app. It's not particularly creative. It does have the advantage that it will trigger, well, I'll get into that a little bit later. The second app is our Interim Messaging App used internally on the satellite uplink. And this was in 2006 we started that, and that is by far and away the most complex and critical of the 3 apps. This was where Postgres really stood out. And then the last one is our infrastructure for monitoring our two-way network, which is used by our network operations people. And that was started in 2009, and that app is the most like what you would think of as a big database app, where you just have kind of unbounded amounts of data constantly flowing through it. So the first one, this one called MyAirMail, it's a simple dispatch system. It looks like a webmail thing, like Hotmail. It's got an address book, and it has the characteristic that that if you send a page and the network infrastructure fails, it lets the operator know immediately so they can roll over to the phone and dial on the phone. Because all of these pagers have phone presence as well, PSTN presence. So our typical customer for that would be like a nursing station in a hospital or a small fire department. What's interesting about MyAirMail was that we started development in late 2000. We went live with the code in late August of 2001. And of course, at the time, this was Verizon. It was a big company. There was a major database vendor. Actually, the application was already up under the major database vendor, but they kept having all sorts of problems with it, so we were called in to rewrite it. There was a lot of politics about using Postgres. It was 7.3, I believe, was the version we went with, which was not, in comparison to where Postgres is now, maybe that was a little risky to use 7.3, but after having met Bruce and Tom and knowing the history of Postgres through Ingress, we were pretty confident it would work. The application is pretty simple. Most of the messaging is done downstream from the app, but it is forward-facing to the customer. So guess what happened? So we went live, I think, in the 3rd week of August, and 3 weeks later, 9/11 happened. Well, when 9/11 happened, and all the cell towers got knocked out, guess what worked in downtown Manhattan? Paging. So all of a sudden, we escalated way up, and it was an absolute traumatic effect on the company and the critical messaging, because we were able to paging was working because of the redundancy of the simulcast towers. Postgres was under scrutiny. Now, this app was not responsible for delivering the messages, but it was facing the customer. So we got a phone call from some senior VP at Verizon, and things were just very, very chaotic, and Postgres ran absolutely perfectly. It was flawless. We had no problems at all. Frankly, we were a little worried about it. I had a laptop set up next to my bed, watching Apache logs. Never had any problem at all with it. The volume on that system was around 100,000 users. Today, this application has dropped down to somewhere around 5,000 to 10,000 that actually log in, human beings. So it's dropped, in percentage with paging dropping. We also have about the same number on anonymous IP. So this application is deprecating. It's still reasonably popular. We have not done any maintenance on the code probably in 10 years other than database upgrades. So it's been a good profit center for us. Here's a screen snapshot of it. Like I said, it just looks like a typical web app, nothing fancy. Oh, I forgot to mention on the 9/11, I was scheduled to speak at the open source conference for O'Reilly in New York, which was about a week after 9/11. So I had to cancel when 9/11 happened, and Bruce got a little upset about that. And we also had, if you remember right after 9/11, there was the anthrax scare. Well, what happened was the doctors, it's called CMAS, is a critical message application the government runs. I think the FCC runs it. And all the doctors, they had to test their messaging infrastructure. So back in 2001, pagers were quite popular. We had about 4 million customers back then. So they literally coordinated everybody. They logged into MyAirMail, all of our customers, and all sent emergency messages to all doctors simultaneously, trying to simulate a sudden outbreak of anthrax, say on an airplane. And this was just a couple of weeks after 9/11. So in the middle of all this sweating over whether Postgres is going to work or not, we have to go through this formal process. So we didn't get any sleep for a week. And literally the doctors would say, okay, I got, all of them would report back and say, okay, I got the message. We had to cross-reference failures and make sure it wasn't something in the application software versus the RF network. And Postgres came through fine. It was fantastic. So we saw these huge spikes in the traffic when literally everybody's going 1, 2, 3, send, because they're trying to simulate, the high traffic. And it ran fantastic. So here is the network topology for that application. Like I said, this has not changed in 10 years. This has not changed much at all, really, in about 10 years, or maybe even more. Here's the internet on the left. We come into your standard kind of LAMP type, Apache, Perl web application. We do something that is traditional in the telco business. I've seen this done a lot, where they run an application level transaction log, which is just a fancy way of saying it's a text file with a line entry on a change. These applications are very structured. There's not a lot of ad hoc querying going on, because this is facing the customer and responsible for delivering messages. Should they need to do ad hoc type report querying, we would dump it and give it to like our marketing group or something like that. We would never have the marketing group actually querying a forward-facing database. They don't need to know data that, within a day is usually accurate enough. So what we do is we run this application transaction log, which actually has the ability to replay back in at a point in time. The programming is pretty simple. It's just address books. We do PG dumps every 4 hours on this database. This is the one that started on 7.4. Today it's running 9.3. We also are now running asynchronous replication on all of these. We didn't add that till fairly recently. Frankly, I wouldn't say we had any issues, but the feedback I was getting from my associates was that the replication in 9.0 Postgres 9 or 9.1 was not that good, so we didn't try to do it. We were happy with having this ability using PG dump. These are mirrored and they sit behind a virtual IP address. One of the things you learn in critical messaging is it's more important to come up quick than it is to try to. We can tolerate losing 10 minutes worth of stuff. We could tolerate even losing an hour's worth of stuff, because our application logic knows how to replay. It's kind of cheating a little bit, but it's practical, because we absolutely have to come back up. The volume of updates is light enough that we can get away with that. If we don't get back up, then we have SLA issues. We have to write postmortems. We possibly might have somebody who died because of it. IT departments have hospitals have very good IT departments, very, very good IT departments. So things are all logged, and that can translate into liability for us. So bringing the system back up quickly is absolutely critical. Okay, any questions? Okay, we'll go on to the next one. So this next app is, this is the one that was, this is the most complex of the apps that we moved to Postgres. This is the application that was responsible for programming each of the 1 million devices on which frequencies they go through over the air. So it's not a one-to-one correspondence between the frequency on the pager and the device itself. So, for example, a pager may be listening to several frequencies at once, depending on whether they have nationwide coverage, state-level coverage, city-level coverage. Also depending on traffic, and because we're always trying to distribute across the frequencies. So when the program, We cannot do over-the-air programming on frequencies. We can do over-the-air programming on groups. It would be nice if we could. We're kind of looking at doing some of that. That gets tricky. You can brick things pretty quick if you don't get that right. So the frequencies are actually hardwired into most of the pages. I think one of the newer pages we're doing is able to do that. So Postgres was going to be responsible for this. So all of the forward-facing internet traffic on all the protocols, email, SNMP, WCTP, SMS, all of that was going to run through the Postgres database, including the spam filtering. So what happens when you're Verizon, you get hit really heavy with spam filtering all the time, constantly. When Roy acquired the company and branched away from Verizon, we didn't inherit the high-quality spam filtering that you run on your cell phones today because they rerouted the traffic through our server, now the new company's servers, and that cut off the first forward-facing level of spam filtering. So we actually had to develop our own in-house spam filtering. We have the advantage of that there's a lot of structure, and it's not like your typical email. There's a lot of structure in the data. We were quite concerned when we flipped over this system to Postgres that would be a problem on the load. We weren't quite sure. So we also track the message reply history. So when you reply on the two-way protocols, not on the one-way protocol, this system generates millions and millions of updates per day. It's hard to predict totally because the runaways and the spam messages can spike that really high. Every time a message comes in, it increments a counter, does an update. The database keeps a moving window using SQL to do all these queries. The system it replaced was a distributed system where the message would come in over the internet. It would then go out to what's called the home terminal, the physical location. There's always a home. In the old days, you had what's called a home terminal in a cell network or a two-way network, RF network. So it would go all the way out to, say, Milwaukee. Milwaukee would then say, oh, that's a satellite page, and send it all the way back to Dallas and back up again. So you had this 2 or 3 second latency, and all of these terminals had these dedicated links, thousands of them. So that had to go. When you think about it, that's stupid when it comes in. But this is a historical system that evolved by acquiring companies, merging things together. And you don't just bring down a nationwide network, right? And then, okay, we're going to go down for 10 minutes. It just doesn't, it's not even a concept. So when we decided to centralize this by running the traffic into Dallas, look it up in Postgres, shoot it up the satellite, which knocks off seconds off the latency, this was a big deal. And that meant we had to take all the programming out of all these terminals, and there were different vendors, different types of terminals, and translate that into relational database tables. This was probably a year's worth of work of planning to do this. Code-wise, it wasn't particularly hard. It's just the accuracy of the data, how well we did the translation. It's really difficult to test in live large networks. Fuzz testing only works so far, and it often can just give you a false sense of confidence. So because we don't really have test frequencies, we have a few, but generally speaking, we utilize all of our bandwidth, so it's really quite difficult. You essentially get a bottleneck through that. So anyway, here's a typical example of the kind of stuff that Postgres tracks. This shows all the frequency mappings and what are called paging groups. And this is essentially where it says, okay, it comes in on one from the internet. We look it up, it gets mapped onto these frequencies. The downside of it has to get retranslated again. And there's a whole bunch of these rules that got pulled out of all these different vendors. We actually contemplated bringing Joe Selko in on this. Turned out we ended up being able to do it ourselves, but it was a complex enough project that it was a lot of work. So here's that network, and the blue boxes are Postgres right here. So we got 4 big Postgres systems running on this. We do every trick in the book to keep it as reliable and running as possible. So for example, we start right here. This database at the top is this is the route table. It's only about 1 gigabyte, which is small. The update is only done through spreadsheets, and it's done more formally. So if we bring a new frequency online and we have certain characteristics, we bring that into that table. So we run a PG dump on it. We can also replicate it just from the source data. It updates maybe once a day, maybe 2 or 3 times a week. So the forward-facing applications, when they have to figure out the routes, only or read only. The second, and all 4 of these are logically segregated, so we can bring them down independently. We do a PG dump on the backup, All of our databases now do asynchronous replication. But with regard to training, these are PG dumped and then brought back up live, and they sit behind VIPs. So if a database were to crash, we have not had a problem in 9 years, by the way, but if a database were to crash, or a box were to crash, then we would point the VIP over to the possibly up to several hours delay. We do 4-hour dumps. And then do the same trick with the reprogramming and catching back up. We would not probably go and try to figure out why the database was down and what we're going to do about it. We just point the VIP, it's back up. I know it's cheating, but it works. And like I said, it's more critical to get message flow back again. We do not do replication across data centers. We only do the asynchronous replication within each data center, but we do mirror the PG dumps across data centers. So the second database in the middle is the one I was showing you in the slide here. This is the detail on the 1 million or so subscribers that tells which frequencies they go on and what services they have and things like that. That's about 10 gigabytes. All four of these, by the way, are running 9.3 Postgres on very beefy hardware. The same thing here, we do a PG dump. Now, when we brought this system up, the provisioning call center, when people call up and say, I need to do something on the pager or the website, is a legacy system that is about 30 years old. So it runs on true 64 Unix, by the way. And it actually talks a protocol in the paging network, just like in the cell network, there's a protocol for provisioning when you want to program a cellular device, there's a protocol called GCP. And actually, our provisioning system speaks GCP and does not speak SQL. So instead of this was a bit of an issue for us. So instead of changing our billing system provisioning software to speak SQL, which was not practical really, because this billing stuff gets really complicated really quick, we spoofed a paging terminal, and I wrote the GCP that just looked like another terminal in the network, except it was nationwide. So we didn't have to change anything on the SQL side at all, and that programs in the provisioning network, and it also runs, and this legacy application here running on True 64 does the same trick running its own application level transaction logs, which is nothing more than a line in a text file. So it says make the pager look like this. So it was either added, deleted, or changed. It's pretty simple. They routinely do statistical polling on this to make sure the terminals are programmed, because this layer right here, the non-internet portion of it is responsible for programming thousands of terminals that are on all sorts of unreliable links, dial-up links, all sorts of things. So there's a lot of code at the application level to say, make sure what I said was there is still there. And in the old days, a field tech would actually have physical access to the terminal and sometimes program stuff. So, so this software has the ability to resync, essentially, fairly quickly. And like I said, it does sampling, all this kind of stuff. So that means we're read-write here at this boundary on the terminal, but I mean, once again, that means the application software is read-only. So when we want to upgrade or do something, we can actually cut this off, and it's queued up here through the application level, and upgrade, say, Postgres right here, and what happens is just the last 10 minutes worth of pagers don't get turned on or reprogrammed. But the system as a whole is still running. So we play. And then the third one is, this is the one we were most concerned about when we went live. This is what tracks the runaways. When you deal with a lot of hospitals and IT departments, you get runaways where somebody's just banging your network. That is not so much an issue at the Postgres level, but it's a real issue at the RF level. It can cripple an RF network because the RF bandwidth is much, much more expensive than the internet bandwidth. So there's a lot of throttling that goes on here. We have enough structure. A lot of people say, how can you guys run 1 million customer networks spam filtering? Well, when we got quotes from Barracuda, for example. Barracuda's largest customer, this is as of 3 months ago. We actually got another quote recently. Over Christmas last year, we got another quote because we had a denial of service attack. But they had their largest customer base was 75,000 addresses. You have to program them all customers. So 75,000 addresses was their largest customer. So that would make us 15 times bigger than their largest. They quoted us $36 million in the initial quote. Okay, we're a small company, so because they're charging a couple dollars per month per subscriber. I think that was $36 million a year, not a month. $36 million a year. That was the initial quote, so that was highball. But they also said you'd be by far and away our largest customer. We got similar kind of quotes from some other vendors. So the reason we did it recently is because we had a terrible denial of service attack that really affected us. We do this layer right here builds profiles. Because we have a lot of structure on our email, we can make assumptions you can't make in Hotmail or more international. One, we're mostly American. We have a few customers that run offsite stuff. Two, most of our big customers have IT departments and do proper publishing of their source SMTP servers. So essentially what we do is analytics, and we do what's called negative routing, where if we get under a denial of service attack, we can flip our SMTP servers to block everything, right, and then only accept from a proven list. So that's a hack, and it's ugly, but it works, and it keeps 98% of our traffic flowing. If you've ever been through a real denial of service attack that's distributed, it's a nightmare. Some of the people that provide protection for that are so good at it, you wonder if sometimes they're actually starting the attack. I've heard they're so good at stopping it. So, so Postgres handled that real well. All of this got, and then the fourth system is our two-way reply histories. This does peer-to-peer replication. All of these talk to each other and copy the message in, and then it just round robins through the, so this is, I guess, a multi-phase commit at an application level. So the app just goes right. And then it just round robins on the load balancer on the read. So this is a very lightweight, this system's extremely lightweight. This system, the throttling system grows up into the many gigs sometimes, kind of depending on what we're recording. It typically doesn't get more than maybe 50. Depends on what's going on the network and what things we're tracking as far as the runaways and things. We do get a lot of runaways. It happens regularly. Where a guy will write a shell script, that just sits there and bangs away. And like I said, it doesn't really affect performance at the internet level, but it has dramatic effects downstream on the radio frequency network. So we went live with this pretty much the whole system in one shot. So we had it mirrored on one of our other backup satellite uplinks, sending essentially just black hole traffic, and we literally threw a switch, and it worked flawlessly. We've had no real issues with this. We looked at using Skype's queue thing in Postgres, but we never have had enough of a performance issue. We were a little concerned about the way the messages are queued is just brute force queue. Select where the time is the oldest. There's nothing fancy about it. Just acquire the lock, select, get that. A typical traffic is about 100 messages a second, just pretty light by a lot of messaging standards. We get paid by the message though. But we've had no real issues. We had a little tuning with the vendor on this. We would see garbage collection seemed to always get better, but we never really had anything from a user network monitoring point of view, latency point of view. We never saw anything at the application level. It's behaved like a champ, but we did start doing research on the Skype queuing system. I don't know if you guys are familiar with it, but Skype runs on Postgres. And they have a dedicated queuing system because traditionally relational databases have just been okay at queuing because they're more geared to recording facts. And the whole idea of a queue is once you put it in there is to get it back out again, which is kind of not an ideal environment in a relational database. That has never turned out to be a problem. But like I said, we looked at using Skype as a fallback in case we misread something. We've had more issues with the throttling and the runaways than we have. But nothing that we thought was specifically related to Postgres. One thing we do but this system is absolutely critical to the company. It goes down, we go down. One thing I'll make an observation about monitoring. We don't do a lot of real fancy monitoring on Postgres. We do the usual kind of SNMP on the box, but we don't do specifics on. The reason why is because generally speaking, what causes an issue is not going to occur at the Postgres level. There's going to be something like a runaway or a spam attack or something like that that's actually the source of the problem. The application is structured enough and doesn't change enough that we have a good handle on how to write the queries and all that. We just have not seen that type of problem. The problems that we do get are, like I said, a spam attack is a good example of something so we don't really need to do a lot of monitoring on Postgres other than just basic response time that's measured, what they call user experience in SNMP. Run a full page query all the way through, that drops below 2 seconds, then you fire an alert. Let's see. So this we've been very pleased with Postgres. It's been this has been running since 2006. Not a lot of change to the code. More tables get added, but not a lot of change to the existing tables. Everybody understands normalization. And it's just been really fantastic. This is running 9.3. Probably next upgrade will be 9.5. We have a tendency to skip every other one. The next app is the one that uses the 9.5 and the upsert. Got any questions about this?
Do you do any clustering, like at the physical layer of the server, like where you have automatic failover?
No, we do. That's a good question. No, we do not. In fact, it was Second Quadrant, I think, got involved with this in consulting. It was Greg. We do not do any sort of automated failover in the database. It's too hard. We don't trust our own code. That's what it boils down to. Now we have virtual IP addresses and load balancer, so we can very quickly switch over. But we're going to lose some. We're going to lose some data. The important thing is that we come up consistently at a point in time. No, we don't do anything like that automated. We don't trust ourselves well enough. We have a 24-hour knock that's with the big heads-up displays. I've got the next slides will show all that. So we have a pretty good monitoring infrastructure all the time, and they're monitoring a lot of other things besides Postgres. Postgres is one of the best behaved, least problematic in our network. I mean, we have stuff when you run these tower networks, you have stuff breaking all the time. The weather affects us. We have rain fade. We run heads-up weather reports. Detailed weather reports all across. I mean, there's all sorts of things going on that are breaking. So, the Postgres has been, considering how important it is, that literally every message goes through Postgres and how critical it is to our network. It's been just absolutely perfect. I mean, there's been no issue. The Postgres community is very mature. You ask a stupid question, you get a nice answer back. They're just fantastic. It's just there's never been any issue at all of whether we should go to Oracle or whether we should go to some other commercial vendor or anything like that. At least internally within us. I know in the early days of Postgres, like I was saying during 9/11, when Verizon was bigger, but this smaller company, American Messaging, no, it's been like I said, the big problem we have with using the automated failovers and all that is the people that run this, our network operations, are not database experts. They just aren't database experts. It's that simple. And we so rarely have an issue with the database. So I'm one of the database experts. We have a couple of our engineers I guess you'd call that tier 4. But the guys that do the day-to-day kind of monitoring are not experts. They're getting better at it. They can rebuild off PG dump like crazy. That's easy. They know Linux. They rehearse things. We get them involved when we do upgrades. But at the end of the day, if there was something corrupted on a database or hardware failure, we're just going to flip to one of our several-hour but predictable backups and then replay the update logic into it. We're not going to try to rebuild anything offline. I mean, we will, and they do know how to work with load balancers. So they're dealing with network flow and system flow and not so much the details. They would be uncomfortable having to go in and roll back or do some kind of a recovery. We are running the asynchronous replication, but we're really more doing that just to see the effects of the performance on the system. We actually have never rolled back to a broken relational database. We had disk drives go out in the RAID. We do run RAID 5, by the way, on this. Bruce was saying in the talk this morning, don't run RAID 5. I don't know what he's talking about. We've never had any issue with RAID 5. But most of these systems run RAID 5 on ProLiants. But no, we don't do anything super fancy. One of the nice things about dealing with the telco business is they're not afraid to spend money on hardware. So, we just buy bigger hardware and put more memory in it. And they understand that. And we also have a full data center management, so we have people that take care of the hardware. Okay, so there's the last one. This is the SkyTel network. This is the database application that's closest to what you would associate with a really big database. This database typically bursts up to half a terabyte. It is not customer facing. It's used internally. So what we're doing is we're taking the raw RF packets coming off the two-way network, and we're monitoring those packets. So I like to say, imagine if you had a Wi-Fi, if you could go into your Wi-Fi network and do SQL queries over the last 2 weeks. And every now and then, sometimes I want to do something like that. So we actually log every packet, and this sits, and then packets come in on multiple towers, so they get unified. We're looking at device responses. I got 10 minutes. We do not have message bodies. The legal told me to put that in there, so we don't record your messages. But so here's the RF network. This is the SkyTel network in the blue box. We do not touch this network, but what we do is this is mostly Unix network, True 64. We are sync off the logs, and here's the trick that we do. This is a very large amount of data. It's typically 20 to 50 gigs a day. Database, it sits on an 11 terabyte RAID system. And so what we do, though, that's the trick here, is we run, the data comes into a set of servers we call the sketch servers, and they build round-robin database graphs, which, by the way, you can query these, trivial queries, but you can query these. These are lightweight and easy to build. And then in parallel, they essentially SQL copy in to extract out, not the full logs, they extract what they need out, stick it into a big Postgres database, and it just kicks out to the NOC with the big GIS stuff and the overhead monitoring. So the trick is that by splitting it here, we have a level of monitoring that allows me to bring this offline periodically. This is running 9.4 and 9.5. The mirror version of it's running 9.5. The beta or alpha 2, I guess. No issues. This does a lot of what you would call upsert because we're looking for state. We don't really care where it came from. So we're rewriting, I'm rewriting a lot of the queries in here had to do the logical upsert in the code are now being replaced just using upsert. Having no problems with it so far. It's run perfectly so far. So here's the round-robin database graph. This is where we can cut Postgres off and still have most of our monitoring going on to some degree or another. You can do trivial queries on this for the last value, for example, which is what we drive our alerts off of. A lot of times this is all they ever look at. So what changed with the NOC was, like I said, think about having your Wi-Fi network, except thousands of times bigger, with every packet that's ever gone through. That's something that's relatively new in large-scale telco monitoring. So what happened was our NOC guys who were RF engineers, military guys, don't know relational database, started thinking about their network logically. And one of the NOC guys looked at it, he looked at the SQL and said, oh, that's just logic. I know that. That's not code. That was exactly what he said. And I said, bingo. That's why SQL is so important, and that's why Postgres was so important, because if we had to license a commercial database with this kind of data volume, it would have been crazy expensive, and there would have been a whole sort of, minor kind of cultural religious movement. With Postgres, that was easy to do. So they have Joe Selko's books, and they're learning about Postgres, and they think more about what they don't really write a lot of queries, but they understand the complexity of it, and they look at the SQL code, and they go, oh, we need to do this, and we need to do that, and write the query up, and it's done. So the end result of that query back there is here's from the PG Open in 2012. This is where the hotel we were staying at. So this is our tower network surrounding riverfront. So you see the green that means okay. Blue means it's cold. It means it's okay, but no traffic. Red means something bad's going on, and yellow means something's about bad go on. So you click on the icon, and it pops up the detail. All that's stored in Postgres. I think this is Bing, the Bing thing. Google wouldn't let you run them behind a private network. They used to, but this is, and it's nothing fancy. We don't use any of the GIS extensions of Postgres. They're just straight bounding box. Don't care about projections too much. And so, but they can drill in and look at event traffic. They can actually query on particular customers. So, big thing is we look for things that spread across customer bases. So each packet's tagged with the customer ID. So if it's all coming from one customer, right, it's something probably not. It's not a systemic problem that's, say, related to some tower issues. In the old days, you'd roll the tech out there and know something 2 hours later. Now, thanks to SQL, they have a very logical, comprehensive notion of what's going on in the network, and we have this kind of thing all across the country. So 9.0 didn't work. The original system was done in 9.0 with log tables. It was too slow. I tried to load every event in there in the beginning, didn't work. Kind of worked, didn't work, kind of worked. We switched to CentOS 6 and we went to 9.1 and turned off the logging on the tables. That made a huge difference. It was night and day, and I was really surprised how much of a difference it made. Really a fantastic system. The reason why we can use the unlogged tables is because the cron jobs that build all this stuff will actually resync up to midnight, the previous midnight. So they just load things into a temporary table, delete everything, flag everything that's already in the table, i.e. kind of like an upsert, and then just load what's not in there. So if I can always rebuild it up to midnight just automatically. So there wasn't a lot of different, there's no real, it will literally get rebuilt on the next sync. Although it might take a little longer to catch up, it'll still get rebuilt on the next sync. So there's no point in logging on those tables. It's not customer facing. We also have hundreds of gigs of RAM. I keep hearing kind of weird stories about how Postgres can only handle a certain amount of RAM on shared memory. We have not seen that as being a problem. We have run systems of 192 gigs of shared memory, not seen a problem. We throttled it back down to 64 because one of our contractors said, no, you have to, you can't. There's some issues with regard to how it scans free lists, I think, in shared memory. This current system runs with 64 gigs of RAM, 64 gigs of shared buffers. Never had a problem with it particularly. It's lightning fast. So I got 5 minutes. We're doing new application. I don't have quite time to get to the VoIP stuff. But our new application is replacing the old IVR monitors, the PSTN network. We're using the vendor's using Postgres with that. So it's big surprises. So those are when you answer the phone, you call in and you get the voice prompt and all that kind of stuff. We're replacing that legacy system with a Postgres-based system. And so that's not in production yet, but that'll be the next kind of big application we move into production. I guess that's it. Or any questions? No questions. Well, thank you for your attention, and it's a pleasure for me to be able to give back to the Postgres community. I kind of feel like we've gotten more than we've given, which I grumble about sometimes with the management. But it's been a real pleasure being here. I know it was the open source database conference. I don't think they have it anymore. It was O'Reilly sponsored. O'Reilly sponsored it. And they had one in 2000. That was the first one at the Hayes Mansion.
I think I remember that.
Yeah, and then they had the second one was in New York, and that was the one I had to miss.
Okay.
Yeah.
Which was the one where you met Bruce?
That was the one in Hayes in San Jose in Hayes Mansion, and that was kind of the coming out for Postgres. That was the one where MySQL was there, and we got into arguments about. And MySQL was really bad back then. It was like.
That was about the same time I met Bruce and Tom at the O'Reilly conference in San Diego.
I'm trying to think which one. Well, this was the O'Reilly sponsor. This I'm pretty sure. It was called the Open Source Database Summit. Open Source Database Summit.
It was a different one. I met them at OSCON. OSCON was in San Diego in 2001.
And that's more just general open source, right? Yeah, this was the Open Source Database Summit, and everybody was there. Mike Olson was there, Cloudera's president. It was a really good, beautiful location, the Hayes Mansion, and yeah, we knew Postgres, we knew Ingress really well through Britton Lee, and knew we weren't getting in trouble. But actually meeting Bruce solidified it, and I just want to know, was there going to be a heartbeat there? Was it because Postgres was still pretty new in 2000 and pretty raw, really. But the nice thing about Postgres is it's always moving forward. They don't make a lot of mistakes. The query optimizer in 2000 wasn't really very good, but it wasn't wrong. That was the main thing. We could deal with, we could work our way around that. And the problem we had with MySQL is they were just so flippant about it. Just basics in transaction stuff. I mean, it was clear to me they were flippant about it because they didn't know how to write code. I mean, that's probably too strong a statement, but I mean, I was really surprised how flippant they were about the whole thing, and I've always said, MySQL is not faster at all if you have to write complicated queries. I don't want to write all that stuff in my application logic.
Interesting. I was talking to Grant McAllister, who runs the RDS for Amazon, and they, of course, do Postgres and MySQL as well as Oracle and some other things. But he was just talking about the fact that he needed to look for a chance for the next Postgres RDS release to get something in that he needed to get in because they don't have to do a Postgres release very often, whereas he said they have to do a MySQL release every month. And he said the list of bugs
To fix the
bugs, data-eating bugs, every single month is like astonishing.
Yeah, we have the opposite problem. I grumble sometimes we're running 9.3 mostly, and I grumble sometimes about not, we're, like I said, we go every other release generally. It's a big deal for us to upgrade the database. I mean, it's a several day, all-nighter type, everybody's sweating and worrying. But yeah, we've had just the opposite problem. We've had so few problems. There was that security issue. There was a data corruption bug that came out, which I don't think is in the 9.3, I think it's in 9.4. There was an issue.
There have been some issues with multi-transaction rollover problems.
Yeah, maybe that was what I'm thinking of. Yeah, it didn't affect us. We looked at.
It's very workload dependent whether you would run into it.
Yeah,
Under certain workloads, it could be very, it was a problem.
yeah, it's, yeah, I get shivers from people that when I talk about, we don't get too pedantic about keeping everything synced exact and all that. I mean, that to me is a common model in the telco business. Telco is used to gear going out. They're used to it.
I'm impressed that you're running